In Part 1, we saw how to connect a simple ESTOP switch with dual contacts directly to the drive safety module to quickly disable the output of the drive in both standard STO mode and a time-delayed mode, which gave us more control over how the motor's torque was released. Well, that seemed to work well, so why would you want to add a safety relay? Safety is all about risk reduction, and the level of safety you get requires you to do a thorough risk assessment to help ensure you get the system integrity and performance levels you need for your application. Safety relays are designed specifically to help you reduce risk to an acceptable level. In this video, we'll show you how to use a safety module, but it's important to understand that it falls on you to figure out if it's appropriate for your application, and if so, how best to use it in your system to reduce risk in an industry-compliant way. I'm using the same single-phase 1-horsepower drive and safety module that we used in Part 1. See that video if you need a refresher on how to install and use the safety module's modes. And we'll also use the I/O module's 24-volt supply to power everything again. You can use the drive safety module with any safety device. Maybe you want to shut a machine down when someone breaks light curtain beams, or a door gate opens and trips a safety switch, or a cable pull interlock switch gets tripped, or a trap key system gets activated. You just pick the safety relay that's designed to work with that kind of safety device and wire it to the safety module. For this video, we'll stick with the ESTOP button we used in a previous video, so we'll use this 2-channel safety relay that's specifically designed for things like ESTOP buttons and safety gates. Let's take a minute to understand how the safety relay works. It'll give you a better appreciation for why safety relays are so important. The ESTOP button is wired like this. The safety relay sends known voltage pulses out S11 and looks for those pulses on S12 to continuously verify the contact is wired correctly. It also sends different voltage pulses out to S21 and expects to see that on S22 to test the other contact. And if the relay's cross-fault detection switch is in a down position, the relay will even detect if the contacts are cross-wired. So if a wire gets cut, or even if some other wire shorts to it, the safety relay is going to know it's not correct because it won't see the expected coded voltage pulses. And all of that ensures that the ESTOP switch is actually going to work when you need it. As long as the ESTOP is not active, these switches are closed, and there's power to the safety relay, then these contacts will be closed, which allows power to flow into the safety module, which allows power to go out to the motor. If the safety relay loses power, or either of these ESTOP contacts opens, then these guys open, and the drive cuts off power to the motor. And remember, the drive totally cuts power to the motor, leaving it to free spin down by itself either via the STO mode or the time control mode that we covered in Part 1. Now all of that assumes you have these two pins shorted and the safety relay has automatic start mode enabled via this switch inside the safety module. If instead you switch the module to manual mode, and then we connect those terminals to a momentarily normally open switch, then the safety relay has to see the ESTOP reset and then see this contact close before it will allow power to flow to the motor. That's for safety systems that require you to release the ESTOP and press a second button to force you to acknowledge that you've verified that everything's okay before it will allow power to flow. For example, maybe you have a machine in a gated cage to protect the operators. When someone enters the cage, a safety switch trips the safety relay, which triggers the drive's STO and shuts the machine down. When the operator closes the gate, the STO condition goes away. But the machine doesn't start yet because all it knows is the cage door is closed. It doesn't know if the operator actually left the cage. With a manual reset, the operator has to manually press a button outside the cage to reset the safety relay. That ensures the operator is clear of the machine and it's okay to restart. So that manual restart is really important for applications where there's immediate danger to personnel. Well, hopefully you see why these safety relays are so important. They continuously verify that all the safety circuitry is functional using coded signals to ensure the wiring is correct and not corrupted by other wiring, which gives you confidence it'll work when you need it. And they can require you to manually verify everything is okay before allowing power to flow to the motor. Well, that was a lot of talking for something pretty simple. The good news is, all we need to do to get this to work is wire the system as shown here and push these two white dip switches down to tell the module we're using a safety relay and not direct dry contacts. There's no parameters to set or any drive configuration at all for the basic STO mode. Here's our ESTOP button, the safety relay, the CFW500 drive, and the manual reset push button. I'll push those two switches on the safety module down to tell it we're using an OSSD compliant safety relay. OSSD is Output Signal Switching Device. That just means the device provides those coded voltage waveforms to test the wiring instead of the dry contacts that just provide continuity. Power up the drive. Uh-oh, we have a 160 alarm code. That says STO is engaged. And if we look at the safety relay, we see these LEDs are off, which says the internal relay contacts are open. Why? Well, because we have the relay in manual mode. We have to manually tell it it's okay to let the motor to run either after a fault or on power up. So I'll hit the manual reset button telling the relay I've verified everything's okay, and yep, the alarm went away and we see the safety relay's LEDs say it's good to go. Let's spin up the motor and hit the ESTOP. The motor free spins down because the drive safety module is currently configured for the basic STO mode. That's going to take a while. Okay, the motor finally stopped spinning, so I'll release the ESTOP. We still have an STO alarm, and the relay's LEDs aren't lit. Why? Well, because we haven't manually told the safety relay everything's okay. I'll do that, and yep, the alarm went away. If I remove this cover and switch the relay to automatic mode, I'll put the cover back and spin up the motor and hit ESTOP and let the motor spin down. Now if I release the ESTOP, the alarm gets cleared automatically. The relay doesn't require the extra verification step. Exactly what we expected. We could repeat all of that using the time-delayed version of STO, but it'll work the exact same way as it did in part 1, so we're not going to repeat that here. But it is worth noting that the CFW500 drive's time delay mode does still get you the SIL3 PLE Cat4 rating. That ought to be enough to get you started with using safety relays and the CFW500 variable frequency drives. Click here to learn more about the CFW500 family of variable frequency drives. Click here to learn about Automation Direct's free award-winning support team, and click here to subscribe to our YouTube channel to be notified when we publish more videos like this one.